Hello everyone and welcome back to the World Cement podcast with me, your host David Bizley, Senior Editor of World Cement. In this episode, I'm joined by Ryan Gilliam, CEO and Co-Founder of Fortera, the California-based low-carbon cement company. So grab a drink, sit back, relax and settle in as we spend the next 20 minutes or so exploring a new low-carbon cement technology, getting to grips with the challenges around meeting standards and securing buy-in from end users, asking what it takes to build a low-carbon cement company, and wondering what the future looks like for low-carbon cements in general. Enjoy. I just wanted to take a moment to remind you to register for World Cement. It's free of charge and gives you access to the latest issues of World Cement, both in print and online. Every issue comes packed full of regional analysis, technical articles, project case studies, and the latest industry news. Simply head over to worldcement.com, click the magazine tab, and register today. It's as simple as that. Happy reading. So, Ryan, welcome to the World Cement podcast. Great to have you with us.
I've been looking forward to this. Thanks for inviting me.
Okay, so let's kick things off with some introductions then. For those who don't already know, tell us a bit about Fortera. How did you guys start out, and what's the company's mission today?
Yeah, so the mission of Fortera really is focused on paving the way to zero CO2 cement. And the way we do that is by working with the cement industry, partnering with them, bolting our technology onto their existing plants, and allowing them to actually capture those CO2 emissions and put it back into the product. And so that is the focus of Fortera, but it really has been a long journey to get to this point. And so just to give a bit of background, back in Climate Tech 1.0, there was a company called Calera, which was one of the first companies really focused on trying to reduce CO2 emissions in cement production. And so I was actually an early scientist into that company. Actually, a lot of Fortera employees were also at that company. And that company was very successful in creating a new type of cement that was actually 44% by weight captured CO2. And in that early company, we went through hundreds of thousands of hours of R&D, 5 years of piloting, created 100 plus patents, put 100 tons of it into real world applications. So it was a really successful company technically, where we created this new cement that was almost half by weight captured CO2. The challenge with it was you fundamentally didn't work from an economic standpoint. In those days, everyone thought people would pay for green and pay for CO2, which I think we've all learned that there's a drive to solve for CO2 emissions, but it has to be in a way that's actually economically competitive and works within existing industries.
Sure.
And so for Fortera itself, really the fundamental difference is we took that technology that we had already scaled and proven out in the Calera days as the foundation, but approached it from the perspective of how, instead of trying to compete with the cement industry, how do we actually work with the cement industry and give them an opportunity to reduce CO2 emissions, but in a way that you're doing it economically competitively and with a product that fits under the existing regulations and will be adopted and used within the industry.
Okay, so the product line you've developed then is called React and comes as both a 100% Portland cement binder replacement and as a performance enhancing supplement blend. In a world where we're seeing, an increasingly diverse range of low carbon cements and related products, tell me what's special about React.
So it's a good question, and I think it's one that I'd like to address really in kind of two parts. There's the technology piece of the product specifically that's different, but it's also the approach. And to me, to bring any new cement to the market, it needs to solve both for performance and the tech product side piece of it, but it also needs to be done in a way that actually fits within the industry and is economically competitive. And so from a product tech perspective first, the material we make is effectively limestone. So limestone is the main feedstock into cement kilns. It's 80% of the feedstock. We still take that limestone and put it through the kiln to make lime and CO2. And then we add what we call our recarb process, where we then recombine that lime and CO2 to make React. So I've always said this a little bit comically. We're basically taking limestone and turning it into limestone, but we're going from an inert rock to a form of limestone, or what they call a polymorph of limestone called diatorite, which is actually reactive. And so the benefits of that is React itself is limestone is 44% by weight CO2. So the material we were making is almost half by weight captures CO2 into the material. But because of the characteristics of the material of React, it can be used both as a partial cement replacement or an SEM alongside Portland cement, or it can be 100% standalone cement that is competitive in terms of performance properties with Portland cement. The other piece of it that makes React, I think, why React works, what makes it different, is that by putting that CO2 back in the product, we effectively make 1.8 times the amount of product out of the kiln versus Portland cement, because we're putting that typical CO2 that would be lost to emissions back into the product.
Sure.
And we can obviously get more detail, but that's really why the economics work. So from a cement plant perspective, it gives them the opportunity to use their same feedstock, use their kiln infrastructure, but then make more product on the back end, which is what drives the economics to work.
Okay. So you touched on it a bit already, but let's talk about how React is actually put together, the recarb plant process. What exactly is a recarb plant, and how does it tie in with existing cement plant infrastructure? And following on from that, what's the installation process like?
So for the recarb process, it truly is what we call a bolt-on process. We are co-locating right beside the cement plant, and we are taking lime from the kiln and CO2 and directing it into our recarb process. Our recarb process is it's an aqueous chemistry process where under the right chemistry conditions, and this is where a lot of our patents and our know-how lie, we can recombine that CO2 with that lime to, again, create these reactive carbonates. And so it's really all about getting those chemical conditions right to make a reactive carbonate on the back end, this polymorph called vaterite that I talked about already. And so when we bolt that onto an existing plant, it really is truly a bolt-on in the sense that it doesn't require the cement plant to change their operations to shut down to be able to add our process. And that again is by design, because the reality, again, these are very large plants that are producing material every day with big customer bases. And the idea of really having to have them shut down or change anything is very difficult for people to adopt a new technology.
Okay. Again, we touched on this a bit, but talk us through what's actually happening inside the recarb plant to make this low carbon cement. What processes are going on?
The first step really is the same thing that's happening already at a lime kiln or a cement plant. You're going to take that limestone, quarry it, crush it, put it through the kiln to make lime and CO2. So that all is what's already in place. What we do is in our recarb process is the first step is we then take that lime and we solubilize it in water. And we do that with salt solutions so that we can get that calcium and that alkalinity from that lime into solution. We then contact that with the CO2 in a second process step. And in contacting with the CO2, again, doing it under the right conditions, you will precipitate out calcium carbonate again. And so that calcium carbonate that's precipitated out, by doing it under the right conditions, we make now a reactive calcium carbonate at a size and surface area that actually is beneficial into both as a blend again into Portland cement or as a standalone cement. And then from there is dewatering and drying. So fairly typical processes from the wastewater industry to separate out our material, dry it, and then it goes into a cement silo or a cement bag to be used.
Okay. Late last year, you announced that React had become the first low-carbon cement to meet all 6 ASTM C1157 categories. For those outside the US, what exactly are those categories? What do they mean? And what was the process of achieving certification like?
In the US, and this is something that is being focused on broader than the US as well, is that there are 2 really types of categories of regulations. So there's the compositional based or prescriptive based, which is very specific to Portland cement. And then there are performance-based standards where it is qualifying materials that are going to perform as needed, similar to Portland cement. So 1157 is performance-based standards. And the 6 categories that exist for that are general use, but then there's also categories specific to high early strength and sulfate resistance and heat of hydration. And the way our material works as 100% OPC replacement is that calcium carbonate, when it goes through its cementing reaction, it's very low on heat generation and low on other categories like shrinkage and other things, and as well also gets to strength very fast. So with our 100% replacement, we can get to full strength within 2 days versus traditional Portland cement, which is be 28 plus days. And so that's why it's able to meet all of those different categories under the performance-based regulations in a single cement.
Okay. Generally speaking, do you think standards and policies are moving quickly enough to support the kinds of innovations needed to decarbonize cement and construction materials?
It's a hard one really to kind of frame up. The challenge of this space is there are a lot of ideas for green cement. And I think if you talk to any cement company, they have tried so many different options out there in terms of what people are trying to do. There's a fundamental challenge of a lot of those may work at the lab scale, but to go from lab scale to actually a commercialized product that's economically competitive and actually can get to the market, there's a big leap in there. I would say that there's a view that regulations aren't moving fast enough relative to the number of different ideas out there from a product perspective. But relative to products that have actually scaled and are getting to market, I think that's a much longer time frame, much higher hurdle to get around. And so what we've seen is we've worked a lot with the regulatory side of how to get people comfortable with our material. And so it is a long process because it does require us sharing data, sharing material for people to test, getting people comfortable with how it performs. It's a long process to get regulation changed, but I think by design, and frankly, it needs to be a long process because you don't want to bring a material to market that's going to have failures or have other issues associated with it. It is a long process. I think it's an ongoing debate within the sustainable green cement world of how to move things along faster. But I also think that what we've seen is that things will change, provided you have scaled and have enough material and have the data to really back it up.
Okay. But looking at another challenge then that often faces these kind of low carbon cements is in terms of buy-in from the end consumer, there's often an assumption that sustainability might come with some kind of drawback, either in terms of lower performance or higher price. Have you had to deal with that kind of perception? And if so, how do you go about winning over customers who might be on the fence?
Absolutely. I think this is the fundamental challenge of sustainability at this point. When you're talking about sustainable cements or green cements, and it's broader than just cement, it's everything in the sustainability space. I think it comes with a viewpoint that if you're going to adopt a green cement, you're going to be taking some performance disadvantage or some cost disadvantage. It's going to mean you have to compromise to use that product. And I think that perception has been created fairly because a lot of the things that have come to the market have shown that they're not going to be economically competitive or they are going to have some challenges on performance. And so for Fortera, what we've been laser focused on is developing the product so that it competes with and actually frankly has performance advantages relative to Portland cement, but doing it in a way that is economically competitive with Portland cement. And that's been a journey that's taken a long time. And one of the other fundamental challenges of that journey is the reason why cement is so cost effective is due to the economies of scale of cement. You build these huge 1 million+ ton a year plants, and that helps really from both a capital cost perspective and operating cost perspective, allowing cement to be as cheap as it is in the market. And so when you're trying to bring a new technology to market like what we're doing, that leap to go from smaller commercial plant to a 1 million ton a year plant is a big leap. But you typically need that leap to get, again, those economies of scales to make the economics work. And so what we've had to show is that in our first commercial plants, we can make a product that competes with Portland cement, whether it's being used as a blend or as a 100% replacement, but competes with Portland cement from a performance perspective, but can also be done in a way that we're not selling it at a premium relative to the Portland cement. And so that has taken time to get down that journey. And I'd say that the biggest thing that we've had to do with everybody that's using our material or every partner is getting them to understand why we were able to achieve both performance and economics relative to the typical perception.
Okay. But following on with the topic of challenges then, overall, what have you found to be the hardest part about building a low carbon cement company? Was it getting the engineering right, securing the financing, convincing prospective customers and partners as we've just covered, or something else entirely? Or dare I say, was it all of it?
All of the above. Again, if you think about what we're really trying to do, we're taking an industry that's 4 billion tons a year of cement, 30 billion tons of concrete. So second most consumed thing on earth behind water. So huge industry. And it's a material that builds our civilizations. It's going into roads and infrastructure and buildings and into applications where you can't accept failure with it. And these are life-bearing applications when you think of bridges and buildings and everything else. And so to bring a product to market that's going to get past the risk stage of people worried about, is it going to perform well? As well as to go to bring a product that not only works in the lab, but can be scaled up industrially. Very big leap to go from controlled conditions with scientists in a lab to produce something to go into the field and operating where you have variability in feedstocks and everything else to make a consistent product. Then to go from that to also then being able to scale it up to commercial plants in a way that's, again, economically feasible and doesn't bring in lots of technology risk in that scaling. And then the last piece of it is financing these types of plants. The one challenge of cement is it's a merchant market. It's not typically built off of offtake agreements, but most of the project finance, project debt world is built off of offtake agreements, so these long-term structured offtake agreements. So there really isn't also the mechanism or this clear mechanism in place for how to fund these type of facilities. So I hate giving the answer of all the above, but bringing something new in a commodity space where it's high capex, low margins like cement, it really is all the above. You have to solve for not just the tech, not just have a cool tech, but it has to be scalable, economic, and financeable.
Okay. So we touched on buying from end users a little earlier, and actually in one of our previous episodes of the podcast, we've heard about how sometimes customers are now placing pretty stringent environmental demands on the product, on the things they're having built. But where have you seen most of the pressure coming from to develop and use low carbon cements? Is that at the moment primarily from governments and legislators, or is it that customer demand? Or again, perhaps a combination? And do you see that balance changing over the next few years?
I think it's already been changing quite a bit since we've even started with Fortera. There was definitely a draw to get into the space where there was view on CO2 regulations or CO2 incentives that really, I think, helped push the industry to start looking at what their options were and how do we actually reduce CO2 emissions in cement. But as time has gone on, I think really what we're seeing is that there are customers, large customers, who have made commitments around CO2 and want to solve for this. But again, doing it in a way that's economic. And for us, we have gone down that road of really trying to build up that customer base. And I know you did this on a previous podcast as well, but it's everything from the hyperscalers and the data centers and that infrastructure that's getting built out. Those are companies that have made commitments around CO2 that are now building, putting a lot of cement and concrete in the ground to build out these data centers. So there's customers like that create a great pull. And one of our investors now is Microsoft. And again, I think that's a reflection of their interest in solving stuff in the space. But what we're also just finding is that there are a lot of people that are specifying buildings that do want a greener solution. And that's helped create this pull that at the ready mix level, we're getting that interest in the product. At the precaster level, at the end user level, we're getting that interest as well. And so it's building up really a whole ecosystem that I think is being driven by there are people out there that want to solve for CO2 emissions.
Okay, excellent. Now then, in 10 years' time, do you think we'll still be talking about low carbon cements as their own thing, or will low carbon have become the default expectation by then?
It's an interesting question, and probably 15, 20 years ago when I started in this space, I would have been bullish in saying it'll be just become the norm. I think what we're going to see over these next 10 years is that there are going to be options, and we very much see ourselves as on that pathway of building out commercial plants and providing that option. But there are going to be options for the end users to decide what type of product they want. Do they want something that's more sustainable? Or frankly, we think a lot of people will adopt us just because of the performance advantages. And yes, it's greener and they'll get the benefit of it being greener, but it's really going to be driven by some of those performance advantages we can give. We make a whiter cement, which has some architectural benefits to it. The fact that it gets to higher early strength fast has benefits to it. In the end, I think it's more about creating optionality for the end customer to decide what it is they're solving for and what they want. That, to me, hopefully will be the norm, is that in any market, people can then decide what product they want. But the reality is, when you're talking a 4 billion ton a year cement market, that's not going away anytime soon. And it really is. Cement's a great product. It lasts incredibly long time. It's incredibly affordable, and it really is what builds our civilization. So I don't see it going anywhere in the near future.
Okay, Ryan, well, that's excellent. Thanks for joining us on the World Cement Podcast and guiding us through the world of low carbon cements. I think that about wraps things up for this episode.
All right, thanks so much.
And a big thank you to everyone in our audience for joining us once again. And if you like this episode, please do make sure to leave a like or a comment where possible. And if you haven't already done so, do make sure to check out our ever-growing back catalogue of episodes. Don't miss out, there's loads of great stuff there. Thanks again, everyone. See you all at the next episode of the World Cement Podcast. Goodbye for now. I just wanted to take a moment to remind you to register for World Cement. It's free of charge and gives you access to the latest issues of World Cement, both in print and online. Every issue comes packed full of regional analysis, technical articles, project case studies, and the latest industry news. Simply head over to worldcement.com, click the magazine tab, and register today. It's as simple as that. Happy reading.